In 2026, coffee technology genuinely frustrates me, and if you're an espresso nerd like me, it probably bothers you too. I love the machines, that's why I review them here. There's a reason my cafe didn't succeed, and that's been endlessly pointed out in the comments in my video about it, and that's because I love the gear and making espresso, but not so much the whole hospitality thing. But the coffee industry has a serious engineering problem that almost nobody is talking about. Ask most engineers who know about coffee, and they'll agree that coffee technology is very, very far behind other industries. The clearest example is the group head sitting on a lot of modern home espresso machines, the E61, which was invented in 1961. That's 65 years ago, basically before computers. Now don't get me wrong, for 1961 this was a genuine revolution. Before it came along, most machines were using a spring lever design, which the barista had to physically compress a spring with a lever to generate extraction pressure. More about that later. The E61 introduced a mechanical pump that delivered a consistent 9 bars of pressure, and a thermosiphon that kept the group head at a relatively stable brewing temperature. It was brilliant engineering for its time, but we're still basically doing that, using the same 9-bar pump with a big chunk of chrome-plated brass sitting there heating water all the time. Now, there's a reason lever profiles are still popular today, because the physics of a spring releasing pressure can produce a really elegant extraction curve. I'm not saying old is bad, I'm saying the industry has been too slow to adopt modern engineering. So here are the areas where the biggest improvements are overdue. Let's start with heating, because this is one that genuinely baffles me the most. A traditional espresso machine boiler, whether it's a single boiler, a heat exchanger, or a dual boiler, is essentially just a tank of water with a heating element in it. You heat the whole tank, keep it hot all morning, and the water sits there burning energy continuously waiting for you to pull a shot. Around 30% of home espresso machines are the E61 groups with heat exchangers, the most inefficient design and the worst for your water. As you'll know if you watch my video about it, boiling water repeatedly makes the coffee taste worse. Sitting water naturally absorbs and releases gases from the air, like nitrogen, oxygen, and CO2. That's why fresh water has a crisp taste. Boiling water drives those gases out, so if you drink water that's been boiled and cooled multiple times, it tastes flat. Go try it for yourself if you don't believe me. Drink some water that's been boiled and cooled. It's not nice. In a cafe that's pulling shot after shot, this isn't a problem because they're constantly refreshing the water. At home, it's something a lot of users don't know is making their coffee taste bad, and it doesn't have to be this way. Then there's the heating up problem. It takes 20 or 30 minutes to properly heat up a boiler from cold, and even then, the temperature drifts by several degrees either way between shots until everything settles. You're sitting there waiting for a 5-kilo piece of metal to come up to temperature so you can make one drink. That's absurdly wasteful of energy. The whole reason machines use that much thermal mass is to compensate for the fact that their temperature control is bad. They overbuild the thermal storage so that the system can absorb fluctuations without the water temperature swinging. But if you have proper temperature control, you don't need the mass. Decent and a handful of other engineers have proven this with what's called boosted heating. You use a thermoblock to heat water rapidly on demand. Then you feed it into a very small secondary boiler or chamber where a precise heating element holds it to within 0.1 degrees C, and you add a small cartridge heater to the group itself for stability at the puck. Equilibrium in 3 minutes instead of 20 or 30, with better temperature accuracy than most large boiler machines. Even modern advanced machines like the Data S that I have here with dual boilers burn a lot of energy just keeping the machine ready to pull a shot. According to my smart plug, I was probably spending 5 times as much keeping the Data S heated for a shot than with the Meraki machine, which uses induction. A company called Halo has been pioneering induction for espresso, and they won the Innovation Smart label at Host Milano for it. I went to one of their events in London to see the machine a few years ago, and it's not a home-focused machine, but much more of a modular cafe design. The Unica Pro commercial machine uses a similar on-demand induction approach, which uses around 5% of the energy that a comparable dual boiler system would use. There is no engineering reason why we're still building espresso machines around big thermal boilers other than inertia, cost of retooling, and the fact that the old way still technically works. I could call this laziness, but really it's just old companies doing things the old way. And when it comes to cafe machines, this totally makes sense. Cafe machines need constant maintenance to keep them working, which means a globally distributed workforce of engineers who can work on the machines and keep them functioning in a cafe all the time, without fail, doing hundreds of espresso shots and milk drinks every single day. Innovating and creating better ways of doing things then also requires you to retrain and update the skills and tools of those maintenance workers, which is a lot harder than it sounds. It's much easier to have them all working on the same style of machines so they don't have trouble going into a cafe and finding something with a more complex internal structure than they're used to. Next thing that bothers me is The vibration pump. A huge portion of home and cafe machines use this part, and it basically works like this. An electromagnetic coil causes a piston to vibrate, and those vibrations push water through the system. It's cheap, small, and it technically works. It also sounds a little bit like a very annoyed giant bee living on your countertop, and the pressure it delivers pulses rather than flowing smoothly. There is no excuse for using a vibration pump in any newly manufactured machine. We have to let the vibration pump die. Just using a rotary pump, a little step up, is better. They use a spinning disc to move water continuously and smoothly, which is why better prosumer and commercial machines use them. They're quieter, more consistent, and last longer. The trade-off is size and cost, but they aren't that much more expensive, probably 15 to 20 euros or so per unit. But even the best rotary pumps are still essentially mid-20th century mechanical technology. Decent Espresso have been quietly doing something interesting here. They've developed their own custom pump for the upcoming Bengal machine, using pulse width modulation to control the current in the pump coil with a much higher update rate to minimize pressure pulsations. It's finer, more precise control than anything you'd get from a standard vibration or rotary pump, and it's quieter too. Now, before I talk about steam, which is one of the most important things for people like me who like doing good latte art, I made this book called the Brew Ledger, so you can easily keep track of your dial-in settings and always switch coffees and come back to a perfect shot. Check the link in the description to buy one. Every sale keeps this channel alive and allows me to criticize and promote whatever I like, and there are lots of 5-star reviews on Amazon, so you know that it's a great tool for espresso lovers. Okay, so let's talk about steam, because this is a really clear example of how a small engineering decision makes a massive practical difference. Most espresso machines route steam from the boiler through a metal tube to the wand tip. Heat is being lost all the way through the metal to the surrounding air the whole time. Even on machines with cool touch wands, it's still just a tube within the metal steam wand, ignoring the entire path of the steam through the machine internally. By the time the steam reaches your milk, it's lost pressure, it's wetter because it condenses as heat is lost, and for a lot of machines, if you accidentally touch the steam wand, you're going to burn yourself. This has been accepted as just how steam wands work for decades. I talked with John Buckman from Decent Espresso, and they redesigned the entire steam wand in-house for the Bengal, which I'll hopefully be able to review later this year, and that gives an insight into just how inefficient the status quo has been. Their new steam wand has a PTFE tube running all the way through, including the ball joint. Steam travels directly from the boiler with maximum heat retention rather than leaking out of all the joints and pipes, and the result is that the Bengal's steam is 50% more powerful than their DE1 XXL. Not from a bigger boiler, not from more energy input, just from not wasting energy to heat loss. The principle, reducing heat loss from conductive metal paths, has been understood in engineering for a very long time. Part of why this continues in espresso machine engineering is because a lot of the parts for machines are not designed in-house. They're off-the-shelf components bought from parts makers. You see them all when you go to a show like Host Milano, which is where all the manufacturers go to see their clients all in one place. Designing custom parts is time-consuming and expensive, so huge companies just continue using the same old components and don't take the time to look at inefficient parts of their machines to say that this could be much better with a few changes. Then we come to temperature precision, which was a bit of an obsession in coffee machine manufacturers around 10 to 15 years ago. Most machines, even expensive ones, regulate brew temperature at the boiler and then estimate what happens between the boiler and your puck based on the thermal properties of the pipes and group head. Now that I have this SCASE temperature analyzer from Kremaloop, I can show how hot the water actually is coming out of the group, and what you read on your temperature displays is often just not accurate. For darker roasts, which older espresso machines were assumed to be used for, this probably doesn't matter much. But for light roasts, where you're trying to extract specific delicate compounds at precise temperatures, is huge. What more companies need to do is control temperature at the group by measuring and adjusting continuously rather than estimating based on rough physics. Depending on how long the machine has been on for and heating up, and how many shots you've pulled, it ends up being a guessing game that doesn't react to the physical changes inside the machine. That approach hasn't been widely adopted, even though the sensors and control systems to do it are cheap and a reasonably mature technology. And a big part of the reason why that is the coffee industry is obsessed with the hardware and mechanics, and often neglects software. I mean, think about what's happened to cameras over the last 15 years. Phone manufacturers couldn't fit a full-frame sensor or a 70 to 200mm lens into a 7mm thick phone. They couldn't be dedicated cameras at the hardware level, so they didn't try. Instead, they just invested enormously in software. Computational photography, multi-frame fusion, AI-driven noise reduction, real-time HDR, the hardware in your phone is tiny and physically limited compared to something like the Sony a7 IV that I'm shooting this video on, but the software does so much work between the sensor and the output that the gap closes significantly, especially for everyday shots. Espresso machine manufacturers, with very few exceptions, have not done this. They're still trying to win on raw hardware, while the actual variables that matter for a good shot, things like temperature stability at the puck, pressure response to flow changes, detection of channeling, adaptive profiling based on bean dose and grind, are all software problems that the existing hardware in most machines just isn't being utilized to deal with. A machine with a single pressure sensor, a single flow meter, and a single thermistor at the group has more than enough data to at least detect a channeling shot in real time and feed that data back to the user so they can adjust dose or grind to compensate so the next shot is dialed in better. Almost no commercial machine does any of this. The hardware in most prosumer espresso machines today is better than it's ever been, but the software running on it is, in most cases, embarrassing. It might just have a PID loop holding a target temperature, or a timer or volumetric sensor to stop the shot, and if you're lucky, maybe some kind of monitor showing you what's happening without either helping you to make sense of it or adjusting to improve the shot. Compare that to a modern car ECU running thousands of calculations per second and adapting in real time to the car and the road conditions. We are decades behind where we could be if this kind of data was being properly used and integrated into smart software. And the same problems exist on the grinder side, although I'm not going to be as harsh here because there's genuinely been a big improvement in grinder technology in the past 10 years or so. Let's start with motors. A lot of espresso grinders are still running on brushed AC motors. A brush motor uses physical carbon brushes to transfer current to a spinning armature, which generates heat, causes wear over time, and limits how precisely you can control the rotational speed. It's the same basic design that's been in household appliances since the early 20th century. Brushless DC motors, or BLDC motors, eliminate the brushes entirely. They run cooler, last longer, they're quieter, and crucially, they give you finer control over RPM. And RPM matters a lot in coffee grinding. I've talked about this in my slow feeder video, but the slower you can run your burrs, the less heat is generated and the less static builds up, so the tighter your particle distribution gets. When you grind at 300 or 500 RPM instead of 1500, you get a more consistent grind size. The Varia VS6 and the DF83V I reviewed last year both let you do this, and it makes a real difference in flavor. A lot of the industry still uses brushed AC motors, even in new grinders being released today, or in old ones that are still selling very well. That's now changing with newer grinders at more affordable price points for home users, like the Turin variable speed grinders, the VS6, the Option O Lagon P64, and the upcoming Buku Moto 80. The Moto 80 is an interesting one because it uses an FOC motor system, which stands for field-oriented control. It's the same control method used in electric vehicles and industrial robotics to get extremely precise torque and speed management from a brushless motor. This lets it have variable RPM, but it also allows the motor to dynamically adjust torque depending on bean load, which should improve consistency of grinding when there are fewer or more beans in the chamber. The other big problem I moan about a lot on this channel is burr technology, which is where I think some meaningful engineering progress is happening, and also where some of the most frustrating failures are. Blind burrs are one of the more obvious recent innovations. Traditional burrs are secured with screws or bolts, but blind burrs have no screw holes and are mounted on pins or a magnetic system. The obvious thing is that this means the entire face of the burr is used for grinding, but the less obvious thing is that using a screw introduces wobbling. Obviously, the hole that the screw goes through needs to be big enough to hold the screw, and any space means that the burrs will move or wobble. So then, the burrs aren't exactly parallel, which means inconsistent grinding. You also get retention inside the screw holes, and on some grinders, this can be a lot depending on the design. I'm looking at you, Mal Koenig. The Zerno Z1 is one of the best examples of a grinder designed from scratch around this kind of thinking. It uses vertically mounted 64mm flat burrs, which means gravity helps push the grinds out rather than letting them accumulate, giving you less retention. Now, I don't like it when people say zero retention. I think that's basically impossible, but it is greatly reduced with more advanced engineering choices like this. Machining to tighter tolerances is also possible with more modern engineering methods. Zerno can align their burrs permanently by design because they attach directly to the housing, so there's nothing to drift. But older manufacturers are not updating, because this would mean changing how a lot of their manufacturing processes are done, and they aren't willing to do the capital investment. Korea's Ozik is doing something interesting with their grinders too, and I got to see one of them at use at Monetaguis Cafe in Madrid. They created a maglev burr alignment system using magnetic levitation to position the burr carrier and reduce contact-based wobble, and it's that kind of thinking you'd expect from large-scale civil engineering. They've had limited international availability and not a lot of YouTube coverage yet, and from what I've heard, the owner doesn't really care about getting attention from YouTubers like me. Hopefully one of these days I can get to play with one. They are a little bit out of my price range for now. And yet, some of the most popular grinders are just continuing with old technology that makes worse coffee. The EK43 is a legendary grinder, I'm not going to pretend it isn't, but burr alignment on the EK43 is notoriously fiddly, and it has been since day one, and it still is. Even a slight misalignment causes a meaningful drop in grind quality. People have been shimming EK43s with foil and bits of tape to get them parallel for over a decade. On a grinder that costs several £1000s and sits in serious specialty cafes, that's something that should have been worked out a long time ago. That's using a workaround for a fundamental engineering problem that the company never properly solved, and given that the EK Omnia still has the same alignment issues, it doesn't look like it's a priority. To be fair, the Omnia did add a brushless DC motor, better access for cleaning, and some smart digital features, but it's still the same 98mm cast steel burrs, still the same basic architecture, and still a massive 28kg machine. I don't know if size is just part of the branding now, but bigger is not necessarily better. At the price they're asking, with competitors that are creating genuine engineering solutions, it just feels increasingly hard to justify. The old joke that espresso machine innovation is just copying what Decent did 3 years ago is something that needs to break down, so we can get innovation coming from all over the industry, both in hardware and in software. If you walk into almost any coffee shop in the world, tell me what you see: a big chrome machine, a Victoria Arduino, or a Synesso or La Marzocco, with the same kind of saturated group you'd find on the original La Marzocco GS from 1970. Yes, it still works, but the internals are built around the same fundamental physics as something your grandparents might have used. The industry has optimized the execution of 60-year-old ideas rather than questioning whether those ideas are still the best we can do. The coffee consumer is increasingly sophisticated. We understand extraction yields, grind distribution, pressure profiling. We're spending serious money on this stuff, especially as the home revolution continues to innovate in many more ways than on the cafe side. So it's time the tech caught up with what we want to create. What do you think? Is this something that bothers you, or are you happy with the way things are as long as the coffee still tastes good? And while I do love advancing coffee technology, the Brew Ledger is one piece of technology that hasn't been made obsolete by software and hardware advancements, so take a look at that in the description. Thank you so much for watching this video, you wonderfully overcaffeinated people, and I'll see you on the next one.